Okay, in this lecture we're going to talk about what's called the difference quotient. Now this is a very important quotient when it comes to calculus. It's given by f of x plus h minus f of x over h. Now where's this come from? Well, let's suppose I have a curve and I have a value of x here. So of course across here we have f of x here. So this is y equals f of x as the function. Then let's suppose I move across from x a distance of h. Then this point here will be x plus h. And so if I go up here, then this is the value here, f of x plus h. That's the y value. Alright, now the important thing to notice here is that if I look at let's just do a triangle here. What's this distance from here to here? Well, of course, it's f of x plus h minus f of x. And you can see that that's what's called the rise, okay, difference in y values. And what is this one down here? Well, it'll be x plus h minus x, which of course is the h. That's why we've moved h this way. And this, of course, is the run. So this difference quotient is actually equal to the slope of this line that joins these 2 points. This is called the secant line. So this is the slope of the secant line, right? The rise over the run of it. And this becomes a very important quantity to actually find in calculus. Now, for example, let's suppose I have f of x equals 2x, take 1. Now, it's important to understand what do we mean by f of x plus h. Now remember, this is functional notation, it's not f of x plus f of h. Be very clear on that. You remember that when I had f of 1, this would in fact be 2 by 1 equal subtract 1, which of course would be 1. F of a would have been 2a subtract 1. So wherever x is, you replace it with this quantity here. So this would be in fact 2 by x plus h minus 1, so this would be in fact 2x plus 2h minus 1. So notice that we're replacing wherever x is, we're replacing that with x plus h when we want to find this. So understanding your functional notation is very important. So let's do this in 2 steps for this example. If I want f of x plus h, by my functional notation this will be 3 by x plus h squared minus 2 by x plus h plus 5. Now this would become 3. Now when I FOIL out x plus h squared, remember I'll get x squared plus 2xh plus h squared. And I distribute the 2 here, negative 2, so I get negative 2x subtract 2h plus 5. And this of course becomes, when I distribute the 3, I get 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 5. Now if I now look at the difference quotient, right, we've now determined what f of x plus h is. It's 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 5. And we're now subtracting off our f of x, and use parentheses so you don't make a mistake. 3x squared minus 2x plus 5. And we're dividing this all by h. So this becomes 3x squared plus 6x h plus 3h squared minus 2x minus 2h plus 5. Now we need to distribute the negative, so it's going to be negative 3x squared plus 2x subtract 5 when we distribute the negative into the 5. So we're dividing this by h. Alright, now let's see what we can do here with simplifying this. Notice I have a 3x squared here, subtract a 3x squared, so that would be 0. Notice I have a negative 2x plus a 2x, that 2 would be 0, so that goes away. We have 5, subtract 5, so that's 0, so that goes away. So I'm left with 6xh minus 3h squared minus 2h, all divided by h. Now you'll notice that there's a h as a common factor in all of this. So we can cancel by h, and our resulting difference quotient is in fact 6x minus 3h subtract 2.